Hey everybody! Today's practice problem comes from Principles of Microeconomics by Dirk Mateer and Lee Kopic. We're going to be doing Chapter 10, Problem number 10. The problem begins by saying, suppose that a monopolist's marginal cost curve shifts upward. And then it asks some questions about quantity, profit, and so on and so forth. So the first thing that we have to do is we have to draw a diagram for monopoly, and we have to actually shift the marginal cost curve upwards. So we have something that looks like the following. We've got, what looks like our regular cost curves or supply and demand or whatever. That we have quantity. I'll call it capital Q here because even though it's going to be individual firm quantity, it is also market quantity because there's only one seller in the market. So I'll use Q for the market. And then we can think about here, all the curves we draw are going to be in terms of dollars per unit, right? When we're talking about a demand curve, dollars per unit is going to refer to price. When we're talking about cost, dollars per unit is going to be, average cost, marginal cost, and so on and so forth. So we can start here and we can say, well, we know a few things. We know, for example, that this marginal cost curve for the monopolist, I'm assuming that our monopolist is not a natural monopoly, and that he has a monopoly for some other reason, so that he's facing a normal marginal cost curve that, like for most firms, is actually upward sloping, that he doesn't have, a flat marginal cost curve like a natural monopoly would. We can also then put in average total cost, and we could say maybe average total cost is something like this. When we have an upward sloping marginal cost and we have some sort of fixed cost in place, average total cost is going to be U-shaped, and it's going to intersect marginal cost at the bottom of this U. So those are really the cost curves that are relevant to our discussion. But what also is relevant to our discussion is the demand side. So we need a demand curve. So maybe we have a demand curve that looks something like this. We'll call it D. And remember, because this is a monopolist, the monopoly faces the entire market demand curve. So this is just the regular market demand curve like we saw with our supply and demand diagrams. And then we also are going to need a marginal revenue curve. Because remember, in order to maximize profit, we're going to be looking for the quantity where marginal revenue equals marginal cost. So we're going to have a curve for marginal revenue and a curve for marginal cost. So I could put this in here. Given what we have so far, our marginal revenue curve is going to look something like this. And we don't specifically go through the math here, but what's relevant to know is that the marginal revenue curve starts at the same point on the vertical axis as the demand curve, but it's twice as steep. So you're going to get something that looks like this here that's beneath the demand curve. And these are the curves that we're going to be looking at in order to figure out what our quantity, profit, etc. is going to look like. Now the problem asks, what is likely to happen to the price the monopolist charges, the quantity it produces, and the profit that it makes? So the things that we're concerned about are quantity, I'll write that down, price, and profit. So those are the things that we want to show graphically both before and after our marginal cost increase so that we can actually compare them. So we can do the baseline scenario here. I'll just use, it's a very exciting day here because we're using different colored markers. So the original case, before we're increasing marginal cost, well, we can say we're going to be setting the quantity where marginal revenue is equal to marginal cost. So we can just look, that's where this intersection is here. And we could say, okay, let's call this Q1 star. And then we could say, well, what price is the monopolist going to charge? Well, the monopolist is going to charge the highest price that it can so that it can sell all this output. And that's conveniently given by the demand curve. So we can just go up here and say, well, what's the price we can charge such that this number of units will be demanded? We can call that P1 star. So far, so good. We could also remember that profit can be represented by this formula. We can say profit, which we call pi commonly, is of course equal to total revenue minus total cost. And if we're talking about economic profit, total cost includes implicit cost. But we could also say that profit is equal to quantity times price minus average total cost. That this is just another way of writing this profit equation. And then we can see that this corresponds to a rectangle on our diagram where the horizontal distance is the quantity produced and the vertical distance is price minus average total cost. Now, I was nice with this monopoly that I drew this monopoly's demand curve in relation to its cost curve such that it actually got to make a positive economic profit, but that need not be the case. Just because you're the only firm in a market doesn't mean that people actually want to buy your stuff. But here we can see, all right, at this quantity, price is up here, average total cost is down here. So yeah, we're going to be making a positive economic profit, and we're going to be making a profit in the amount of this rectangle here. So this is going to be our profit in the original scenario. So then the next thing we have to do is we have to shift our marginal cost curve and see how this all changes. So the thing that we were explicitly told was that our marginal cost was increasing. So we were shifting the marginal cost curve up. So we could shift the marginal cost curve up and we would see something, maybe I'll draw it, something like this here. If this seems like a reasonable marginal cost increase, we'll call this MC prime. But you'll notice that what this means is that our marginal cost is increasing by, some vertical amount. It's not actually the same vertical amount at each point. Here it's about this much of a marginal cost increase. Here you have a bigger marginal cost increase, and so on and so forth. But what's important to keep in mind, at least qualitatively, is that these cost curves don't move independently, right? That marginal cost only counts variable cost, so there's no fixed cost component to it. And average total cost counts both fixed cost and variable cost. So what really happens is if we get a shift up of this marginal cost curve, that's actually going to affect average total cost as well. That you can't really move one of these without moving the other, unless, of course, we're talking about a change in fixed cost. Because a change in fixed cost would affect average total cost, but it would not affect marginal cost. But anytime you're moving this guy, you've got to move this guy as well. And we can think about what that's got to look like. Well, we're going to see an average total cost that's higher by this vertical amount as well, right? And we want to draw this so that the bottom of the average total cost U still intersects with marginal cost. So it's a little bit hard to draw qualitatively, but we probably have something that looks like, maybe something like this here, which I'll call ATC prime. Okay, so it's important to remember that if you're moving one of these guys, you have to move the other one. But once we've done that, and again, we don't have to move demand and marginal revenue because nothing has happened to our consumers' preferences. So you can sort of use it as a checklist, go through everything on your graph, say, do I need to move this? Yes or no? And that way you don't forget about anything. So now, to set quantity, we just do the same thing that we did before, right? That we say we're looking for the intersection of marginal revenue and marginal cost. So now, we'll be doing this in purple. Say, well, the new marginal cost curve is here, marginal revenue is still here. That's going to give us a quantity here. I'll call it Q2 star. And then same as before, in order to find the price that the monopolist is charging, we go up to the demand curve because we're really answering the question, what's the highest price we can charge and still sell all this stuff? And that's what the demand curve tells us. So we can just go up here and we can see that our new price is going to be this. I'll call it P2 star, like so. And then we have to calculate our profit. So again, we have this formula. The profit is equal to quantity times price minus average total cost. So we again have to find a rectangle where the width is quantity and the height is the difference between price and average total cost. You just want to make sure that you're looking at the right average total cost curve when you do this. So our rectangle is actually going to be, well, it's going to be this wide. And then we see here that the difference between price and the relevant average total cost is here. So we're going to get a new profit that looks something like this. And then the last step is to go in through and catalog how each of these variables of interest has changed. So analyzing two of these changes is pretty straightforward. So first, let's think about quantity. We can see graphically that in our example, we of course got a decrease in quantity. And we can think of this shape of the marginal cost and marginal revenue curves and think about whether that always has to be the case. And it seems like here that yes, that always has to be the case simply because the marginal revenue curve is downward sloping. So if we were to shift up the marginal cost curve, it's going to intersect with marginal revenue somewhere to the left of where it intersected previously, right? So we can say here that the quantity when we face a marginal cost increase is going to decrease, and the monopolist is going to choose to produce less than he did before. We can think about price. Again, we see from this graph that the price to the consumer was increased as a result of the increase in marginal cost. And we can see that that's generally going to be true whenever we're facing a downward sloping demand curve, because the price charged is given by the demand curve. And so if we're looking for the price that corresponds to a smaller quantity, by definition, that's going to be a higher price. So we can put that the price to the consumer is going to increase. It's also the case that we can think about this a little bit more intuitively, and we can think back to, for example, more competitive markets where we had a supply curve and a demand curve. We represented an increase in marginal cost as a decrease in supply, and we saw that that decrease in supply resulted in higher prices in the market. So what was essentially happening is that the producers were passing on at least part of that cost increase to the consumer, which is basically the same thing as you're seeing here, that it's most likely not the case that the price is increasing more than the producer's cost increased, but the consumer is actually at least seeing part of that, is at least getting part of that price increase passed on to them. Thinking about how profit changes as a result of this cost increase is a little bit more tricky, but certainly not impossible. So certainly here, the way we've drawn it, it seems like profit decreases as a result of the cost increase, right? That it seems like this purple rectangle is clearly smaller than this green rectangle here, but it's still important to ask ourselves whether that always has to be the case or whether that just happens to be an artifact of the way that we drew these particular cost curves, right? So let's think about how to compare the old and the new profit rectangles. So we know for sure that the width of the profit rectangle for the purple one, for the new scenario, is smaller than the width for the old one, simply because we know that the quantity is lower. Technically speaking, it's not entirely obvious whether the height of the purple rectangle is smaller or larger than the height of the green rectangle, right? That it seems like it should be less, that it seems unreasonable that more than the cost increase would get passed on to the consumer, right? Especially since we have limits on the elasticity of demand that would be profit maximizing for the monopolists in the first place. So it seems really unlikely that that's the case, but technically speaking, we haven't proven that this distance is actually smaller than this distance here. But I can make an interesting case to you to show why the profit after this cost increase actually has to be smaller than the profit before. So go with me here. So before the cost increase, the monopolist really wanted to produce this quantity here and charge this price. So because that was profit maximizing, by definition, that must have gotten the monopolist more profit than if he had chosen this purple quantity here and charged this price. So before the cost increase, he had the option, actually, to get this entire rectangle here. He could have produced Q2 because, hey, he's setting the quantity and then choosing the corresponding price in the demand curve. He could have chosen to produce Q2 and prop up the price in that way, but it actually wasn't profit maximizing for him to do so. So it must be the case that this larger rectangle here before the cost increase was still smaller than this green one. Then when we factor in that cost increase, we're actually further reducing the size of the rectangle. So if we're further reducing the size of the rectangle to get to this actual purple rectangle that we see here, it must be the case by definition that this profit rectangle is smaller than the original one that occurred before the cost increase. And we can say pretty convincingly that our intuition is correct, that this increase in marginal cost is actually going to decrease profit for our monopoly.